Correlation and causation are both relationships between two variables in which change in one will see a change in the other, and it's usually in a predictable manner. The difference is that for causation, the change in one variable causes the other variable to change, which isn't the case for correlation. One example of correlation that is not causation is during the winter months in Phoenix, there's a higher influx of people who move here as snowbirds, and there's also higher rates of depression that are reported in people. That's not to say that people moving to Phoenix causes people to be more depressed. It's most likely due to like seasonal depression. So there you have like a correlation but not causation. Another example is bigger cities tend to have higher average income amongst this people. But that doesn't mean that because you live in a bigger city, you will automatically have a higher income. And also, I wanted to go over an example of a Pearson correlation, because it's a great way to measure linear relationships between two variables. And you can calculate the Pearson correlation coefficient, which will tell us the direction of the relationship and if there is a linear relationship. So for a positive value, it's a positive relation, negative correlation, and 0 means no correlation. So in terms of hypothesis testing, we can hypothesize that for H0, that the correlation between the variables is 0, and that HA, that is the correlation between the variables, is not 0. So looking at this example that I created here, I didn't have a data set. I just made one. It's not like I'm going off of a existing data set. So that's what this code is here for. And then now we had to calculate the Pearson correlation coefficient, and this is done with this stats method. And then I just plotted the points, and this is showing the relationship between amount spent on traveling versus annual income for 2024. This is again just a data set I made up using those that code right there. So as you can see, I printed the correlation coefficient, which is 0.99, which indicates there's a positive correlation. And then for the p-value, it was very, very, very small, less than 0.05. So you can say the correlation coefficient we have calculated is statistically significant, and therefore we can reject the null hypothesis that there is no correlation between the two.